Good morning, friends. We'll start RT level 3, that is numericals. Okay, alpha emission mass decreases, mass number decreases by 4 and atomic number decreases by 2. Beta emission mass number remains same, atomic number increases by 1. Neutron change to proton. Gamma emission no change, a new material formed. So Bx minus 4, y minus 2, then there is plus 1, so bx minus 4, y minus 1. So that is the answer. Something like this may be coming. Sometime it came. So there is 40, 20 and 12 and density type 2, exposure to 2 minute. Okay, from characteristic curve figure 1, an unknown source. This characteristic curve you can find in question books. It is very easy to find from there and you just find and do it, because it is, if it is drawn here, then okay. It is not drawn here, the values you can just correlate. Question answer book level 3. So in the last you will find this graph about last. Unknown source with 2 minute exposure and a density of 3 is obtained at type 2 film under a 12 mm. So with density 3 type 2 film LRE is 2.1. Some exposure produces a density of 2.7 on same exposure produces density of 2.75 on type 4 film under 20 mm. So with density 2.75 on type 4 film, LRE is 1.95. So there you find the difference, then antilog 1.413. So step A is exposed to 1.413 times more than step B to calculate HPL 2 to the power n equal to 1.413. It is stepwise done, so just follow it. It will be easy. So n is log of this by log of 2, log of 1.413 divided by log of 2. That is 0.498. So 0.498 HVL equal to 20 minus 12. Because 20 minus 12 divided by HVL equal to 0.498. So HVL equal to 16 mm. Difference between the step C and B is 40 minus 20, 20 by 16. N for those two. And exposure difference is 2 to the power 1.25, 2 to the power n is 2.38. So step B will transmit 2.38 times radiation compared to step C. So difference between A and C is 40 minus 12 by 16, so 3.36 times. So from the characteristic curve density 3, type 2 film step A, LRE 2.1. LRE difference 0.5 to 6. LRE on step C, 2.1 minus 0.526, 1.57 corresponds to density 1.145 on type 2 film. These are long question answers. Nowadays not coming. But just remember, they can ask small from here and there. Or if they ask, you have to answer, but keep it for the last. Because the time they are giving, so people don't find time to complete this paper. So the best way is to lengthy questions you can attend last. They can ask anything. They will not ask all four. Maybe ask something. So exponential difference between A and C is this 3.36, and then density 3 type 2 film. Step A LRE 2.1 already you see here. And LRE difference is log of 3.3, that is 0.526. Then LRE on step C is 2.1 minus 0.526, 1.57. So 1.57 correspond because it will be less. The density will be less. That's why minus. If it is otherwise, it will be plus. Density is 1.45 on type 2. Then comes something else. Since this type of film is same for both A and B, type 2 is same density. Type 2 and same density, the exposure difference is 2 to the power 20 minus 12 by 16, 1.414 times into 2. So exposure is 1.414 times more than step B to produce same density as that of under A. So exposure for B is 2 into 1.414. It's 2 minutes 50 seconds. Exposure difference between A, B, C. It is 3.36 times less than A. 1.41 times less than A. So now, so they divided it 70%, 30% photon, 70 photons, 30 photons, like percentage. Different type of questions, that's all. So exponential difference between A and C is 3.3 times. Exponential difference between density 2 and 4 on type 3 film. Density 4 type 3, LRE 2.85. Density 2 type 3, LRE 2.52. So difference is anti-log 2.11 times. So maximum exposure differences can be between density 2 and 4 is 2.11. Hence 3.36 cannot be covered. Hence ABC full cannot be covered by type 3 film. So if the source is iridium 192, acceptable density is 2 to 3. Which of these steps can be satisfied radiograph in a single exposure in type 1 film? So exposure difference at A is 1. HBL is 12 given. B is 20 minus 12 by 12 because HBL is given. C is 5 times. B is 1.58 times. So from A to C is 3.174 times, I think. Sorry, A to B or A to B. This is 3.14174. Then comes the difference in type 1 to type for density 3 and 2 until log 2.325 minus 1.8. Well, they find it from the graph. They find it from the graph. It's 2.325 2.325 minus 1.8. So that is antilog is 3.25 times. AB can be covered as 1.5 is less than 3.27. BC can be covered as BC can be covered. No, BC is something different. It is 5 times, so it cannot cover. It is not this one. There is small mistake here. So BC cannot be covered because of 5. 5 it is not 20. Because A to C, the difference we cover. No? Forty minus 20, let us see. No, 40 minus 12. No? Because we have to cover A to C. No? The B to C is 3.175, but we have to cover all. If it is only B to C, then okay. Then if B transmits 100, A transmit 160. So ratio is 1.6. Log relative exposure 0.204. Type 1 film density 3 LRE 2.325. Exposure under B 2.325 minus 0.204 is 2.125. So this exposure correspond to density 2.65 in type 1 film. This type of question will come. It will not long, maybe short type question. TMM step exposure 3 minutes and 160 step exposure 100 minutes. The exposure difference between 100 is 50 minutes. (160 minus 50 divided by 2 HBL equal to 100 by 3. U2 by U1 is 2 to the power n. Is 2 to the power HBL. So 110 divided by HBL equal to log of 100 by 3 by log 2 is 5. HBL is 22. So exposure for 120 mm is 2 to the power n into 3, 27.2. This is 3 minutes. This is 27.2 minutes. So log of 100 by 100 density 0, 100%. Log of 100 by 10 density 1, 10%. Log of 100 by 1 density 2, 1%. Log of 100 by 0.1 density 3, 0.1%. Log 100 by 0.01 density 4, 0.01%. Log 100 divided by 0.011 density 3.958, hence acceptable. Less than 4, so acceptable. So they will give just like this question. They something is passing, this percentage 11% passing, or something like that. So how much is the density? Okay, we'll stop here.